Assalamualaikum warahmatullahi wabarakatuh. In this video, we will present about sustainable product. So, we have chosen plastic and starch cassava to be the sustainable material. My name is Muhammad Daniel NAJMI bin Muhammad FAUZI. I'm from J4EC 1104B1.
And my name is Mohammed Hazan Shah bin Ismail from J4 EC 1104B1.
Okay, plastic waste to construction product. Sustainable concrete is defined as concrete that uses less energy in its production and produces less carbon dioxide than normal concrete. It is also known as green concrete or eco-friendly concrete. There are human actions that create trash such as product manufacture and used material. Plastic waste are one of the solid wastes that are produced in large numbers and cause a considerable risk to our planet's sustainability. When plastic debris reach the water, it causes damage to the environment, economic, and aesthetics, according to reports. Finding efficient alternative methods to recycle this plastic waste would therefore go a long way towards ensuring a sustainable ecosystem. Recycling plastic waste protects the environment and contributes positively to the material by allowing it to be used in a variety of applications such as construction. It is because the largest industry in various economies and the largest consumer of raw materials, the construction industry is a potential area where plastic waste may be beneficially exploited for multiple use. Plastic waste can be used as aggregate in cementitious and asphalt mixes, filler, and insulation in civil construction. Method: plastic waste, on the other side, can be recycled mechanically, chemically, or thermally. Before plastic waste is recycled, it must first be separated, which is usually done automatically utilizing technologies such as heating, mixture, asphalt mixture, compression molding technique, shading, and extrusion. First, what's the meaning of heating in this process? Heating is a thermal recycling of waste materials involve heating the plastic waste at high temperatures, then pouring it into a mold to create new items. Next, mixture. The capacity to include diverse components into cementitious composite during the mixing process has opened the way for the incorporation of various materials into it. As a binder and aggregate, a variety of waste materials have been added into the cementitious composite. Third, asphalt mixture. Plastic waste can be integrated into asphalt mixtures in the same way that it is used as aggregate in cementitious composite. Next, compression molding technique. Compression molding technique is a produce composite components in high production volumes such as automotive components to make a plastic mixture. Shredding. Shredding is a process to cut plastic into smaller pieces for granulation. Lastly is extrusion. Extrusion is plastic is being melted and formed into a continuous profile. This is the procedure to complete the process make a plastic bridge. First is plastic shading. Plastic shading, as we know, it cut the plastic components into the small pieces. Then, second step is the plastic shading product will combine with sand. And the third step is the sand and the plastic shredded will be mixed together. Fourth, the produce of mixture of sand and plastic will be heating at 100 to 200 Celsius. The fifth step is the mixture of sand and plastic will be weighed and they will be compressing and shaping by according to the weight setting. Lastly, the the complete plastic brick will be cooling in a water. This is the finding and result. We can see the first picture is shown a plastic waste collection that we can see many plastic waste that be on the world. Next, the picture is heating and mixing. Heating and mixing is a part of the process to make a plastic brick, and we can see the right picture it shown the compression molding technique that used to compress and shape the mixture of sand and plastic. This picture we can see the produce of plastic product with plastic product. We can see plastic brick, the working path and the percentage. Next is finding result of the type of sustainable materials that come from plastic. First, it shows the polyethylene terephthalate that's being used in cutting into flakes method to produce a lightweight concrete. Second, we use the silica by using the heat and compressing method to produce brick and block and go on the another plastic waste that produce the concrete floor, wall tiles and road paver. Discussion. Plastic plays an important part in our our world to get the conclusion of their use is correct. As a result, using this plastic waste for diverse building application is a workable solution for handling this waste while improving environmental sustainability. This overview has covered a lot of material in terms of current research on the usage of plastic waste. The utilization of plastic waste in construction applications will solve both the problem of solid waste management and the reduction of raw material reserved for construction. Furthermore, the utilization of plastic waste in various construction applications contributes to the circular economy's long-term viability.
Next, we move to the starch cassava as additive brick. Introduction. Brick is one of the building material used to construct a building. Brick also has been evolved from start its use until now. In terms of material, brick can be divided into two types, which are burnt and unburnt bricks. Each of these bricks have their pros and cons in terms of quality, strong, and cost. In some research by Department of Building, Federal University of Technology, Minna, Nigeria, and Department of Architecture, Universitas Bandar Lampung, Indonesia, they found that the burnt brick properties can be improved, such as the moisture absorption, abrasion resistance, and compressive strength, by using cassava starch as an additive in making the bricks. In overcome the waste of starch cassava that usually thrown out or burned, the researchers use it as the additive to make bricks. In other research, the cassava liquid waste which contribute to environmental pollution. So, the problem of environmental pollution can be solved and the making of brick will revolve in the same time. Method. Materials that used to make the brick is cassava, cement, sand, charcoal, and charcoal. Procedure. First, a mold were used with dimension length 23 centimeters, width 11 centimeters, and height 5 centimeters. The waste of starch cassava were dried under the sunlight. Next, all the material in dry condition were mixed with water, about 13% of the total weight of material as a binder. After that, the mix procedure were held at not in direct contact of sunlight. The mixed material was checked by form a circle less than 120 minutes to make sure the mixed material is stable and no crack form. The mixture was put into the mold and dried. Then, the already bricks was stored in water to maintain the moisture. Lastly, the 21 days age of bricks was examined by hammer test. Result: the cement that used for the brick are 625 grams. The sands about 937.5 grams, and charcoal about 937.5 gram. Total of all the waste from all the materials is 2.5 kilogram. The result by means of the hammer test. Sample 1, the bricks from the hammer test get 14.5 Newton per centimeter square. For the sample 2, 12.5 Newton per centimeter square. And for the sample 3, 11.5 Newton per centimeter square. The average of all the sample hammer tests is 12.8 Newton per centimeter square. Figure first shows that the sample weight of cassava the before it add into the cement to make the brick. Figure 2, sample of drying process for the wet cassava. Figure 3 shows that the sample dried cassava. Figure 4 shows that the sample of waste cassava after the process. Figure 5 shows that the sample of waste cassava additive into the mixture to make the bricks. And lastly, for the figure 6, the sample of brick in the mold. Discussion. The bricks with additive waste starch cassava are more dense because of the aggregate of waste cassava is smooth. This factor helps in binding process and compact the material perfectly. The color that occur in blackish gray because the cassava charcoal. The result of 3 samples hammer test in average is 12 Newton per meter square. In the data collected, cassava charcoal can be concluded that it can serve as additive in lightweight concrete of or bricks. This is because the strength of concrete or bricks was improved. As products for construction, cassava is one of the renewable material and can be produced the high quality of concrete and bricks. The cost in making bricks also can be reduced in the same time quality of the product were granted. Conclusion for the plastic wick and the starch cassava is, in conclusion, a better future sustainable concrete or bricks is plastic compared to starch cassava. There are several factors that cause plastic to be chosen as a better sustainable material than starch cassava. The first is that plastic is easier to find. This can be proven when human daily use items are mostly made of plastic compared to starch cassava. The next factor is the selection of plastics as future sustainable material is because that at the same time it can reduce plastic waste in the world. Next, starch cassava was not selected because the resource to obtain it was scarce and difficult to obtain in large quantities. Lastly, in that starch cassava is easily decomposed if left for a long time. It can be clearly stated that it is dangerous to be used as a brick in a construction project. Reference for plastic waste to construction products and starch cassava. Thank you from us.